NET-200. This is day 12, week 6, so it would have been Friday. And that would have been 10. Times 7, 16. Yeah, I think so. Alright. We finished off the last video. We talked about topologies, physical topology, how things are actually connected. So we review some things about cable, UTP, unshielded twisted pair, RJ45 jacks. We talked about the 8 wires. We talked about making cable. I also talked an example of large buildings that had cable runs. A fire would start up here. Next thing you know, the fire was down here. And what was happening was the fire was coming down the cable run. We talked a little bit about how Cisco maybe got its name, rumor mill. So we finished up some topics, talked about cables and the assessment. Talked about that. So, all right, review. We have the apps. The apps link in or connect to the application layer. We present the data, like, is it encrypted? That would happen here. Encryption, is it using the ASCII code? Okay. How are we presenting the data? For example, HTTPS would be encrypted, that protocol. Set up a session, figure out how we're going to transport data, UDP, UTC, we make a segment, then we find the best path, we add an IP address, and then it becomes a packet. This information goes in here. If we're using Ethernet, we create a frame, and we add a MAC address, and the packet information comes in, and now we have the MAC address. So if you think about the encapsulation, inside there we have probably a port number, then we have IP addressing, then we have MAC addressing on the outside. And then the physical layer, how do we move the bits either through wire, wireless, or fiber? So if we look at this, here is that valuable data in there. And then we make a segment. We got port numbers. And to the next layer, it thinks that's just all data. Then we go destination, source and destination IP addresses. So that segment now becomes a packet. Okay, we got this segment, now we got packet, and then we get the entire thing. I'll go out here and mark this. We get the frame. Cyclic redundancy check bits are put in there. It's a check the bit frames. We have the MAC, source, and destination addresses. And then we put this, let's say, so to speak, on the wire. So we reviewed a little bit here the old concept of a hub. A hub, carrier sense multi-access collision detection. A hub would just broadcast out, and whichever device was supposed to get it, got it. Whereas now, switches are much smarter. They'll remember the port. The port will remember the MAC address. Okay, so we even looked at in the lab. So we have other rooms here connected to this multi-layered switch. So this port would actually remember, since they're on the same network, remember the MAC addresses of all those. So if a PC here needs to communicate a PC here, the MAC address would appear there, would send the information to that switch. Alright. On wireless, carrier sense multi-access collision avoidance. So wireless, they avoid a collision. On a hub, there could be a collision. You know, two places could use a hub at the same time, even though we don't use hubs much anymore. Okay, so we talked 802.11, connecting via Wi-Fi, 802.3, Ethernet. So those same things happen. We got a server at Facebook. Once it gets the router, now it would work its way through the best path and maybe end up back here at NIACC. Out here they'd be looking at IP addresses, and then the connection between these two is a data link connection. How does it get from one device to another? Alright. So, if you think about it, the information would come down the OSI model, down here to the physical layer, then we go up, like it was going through routers, go to the IP, figure out the best route, come back, best route, and then eventually end up back up here. So for example, a browser trying to get to a web page. And we'll start, if it went through the, you go like OSI model, so all those things would be set up, get the IP address, get a MAC address, get it, eventually, maybe it goes right out, maybe eventually here, and then it goes out to the internet, and there's routers, and they're going to swap it over to the next router, comes back in, moves the traffic, another router, swaps it back in, moves the traffic, eventually it ends up at the web server, and the web goes up to the web server, and the web server responds, and when it comes back, it may not even take the same route exactly. Alright, that's it.